November 11th, 2025. While thousands of passengers cruised at 40,000 feet over the Atlantic, the sun exploded. Radiation levels shot up to 10 times normal values. Just 2 weeks earlier, a JetBlue flight had suddenly plunged from the sky. Computer errors caused by cosmic rays. On November 11th, it was 50 times worse, and nobody on board those aircraft knew it was happening. At exactly 10 a.m. GMT on the morning of November 11th, 2025, the sun unleashed its fury. Sunspot AR4274, an active region that scientists had been watching nervously for days, produced an X5.1 solar flare, the strongest of the entire year. But this flare was different. Of the roughly 20 X-class flares that hit Earth in 2025, this was the only one that did something rare. It hurled a stream of highly energetic protons directly at our planet. These protons travel at nearly the speed of light, not days, like a coronal mass ejection, minutes. And when they slammed into our atmosphere, they triggered something physicists call a ground level enhancement, or GLE for short. Professor Clive Dyer from the University of Surrey put it this way: this was the strongest ground level event we've seen since December 2006. Let that sink in, almost 20 years. Now, what does that actually mean for you and me? Because what happened in the hours over Britain was unprecedented. Within 1 hour of the flare, something remarkable occurred. The UK Met Office and their Dutch counterparts began launching weather balloons. Not ordinary balloons. These carried highly sensitive radiation sensors developed by the Surrey Space Center. These sensors were specifically built to survive conditions you and I can barely imagine, temperatures of -70 degrees Celsius, near vacuum at over 100,000 feet altitude, more than twice as high as commercial aircraft fly. And what they measured confirmed scientists' fears. At normal cruising altitude, 40,000 feet, radiation doses spiked to 55 microsieverts per hour. Normal is just a few microsieverts. This was nearly 10 times the usual level. Professor Keith Ryden explained it simply: because this type of event is highly unpredictable, it's essential to capture as much data as possible when they do occur. And here's what's remarkable about this. For the first time in history, scientists created a three-dimensional map of radiation levels throughout the entire British atmosphere during the event in real time. They watched as invisible particles from the sun penetrated deeper into our atmosphere than they had in nearly 2 decades. But here's where it gets concerning. Because what this data showed was just a taste of something that's already happened once before and could happen again. Let me give you a number: 60 errors per hour per gigabyte. That's the estimated rate of so-called single event upsets in aircraft computers during the peak on November 11th.
What does that mean? Imagine a bit in a computer's memory randomly flipping. A 0 becomes a 1, or vice versa. Sounds harmless? In a system controlling an aircraft, it can be catastrophic.
The researchers estimate that several high-latitude transatlantic routes received roughly twice their normal cosmic ray dose during the peak. The doses remained far below thresholds for acute radiation effects, but the technical risks to avionics increased significantly. And here's the part that might surprise you. For pregnant women on board those flights, the radiation was a real risk. Not life-threatening, but measurably elevated. Nobody was warned, nobody knew. Think about that for a moment. Right now, as I'm speaking to you, there are probably hundreds of flights crossing the Atlantic. Business travelers, families visiting relatives, perhaps a pregnant woman on her way home. And if another event like November 11th happens, the same scenario plays out. 10 times normal radiation. Computer systems experiencing dozens of errors per hour. And complete silence. Should airlines warn passengers before such events? Should pregnant women be informed about the risks? These are questions we need to be asking. Now, November 11th wasn't an isolated incident. GLEs typically happen once or twice per solar cycle, but the sun had been relatively quiet for the past 2 decades. Most of us had forgotten what it's capable of. The November 11th event was powerful, but it was only about 2% as intense as the largest event of the modern observational era, February 23, 1956. You might remember those years. Eisenhower was president. Aircraft were still made of metal and cables, not computers. And yet the radiation hit so hard that some aircraft received more than 100 times the normal dose. Today, with our electronics-controlled jets, such an event would be... Let me put this in perspective. In 1956, radiation levels exceeded normal conditions by more than 2 orders of magnitude. The November event, as strong as it was just 2% of that. But even 1956 isn't the limit of what the sun can do. Cosmogenic isotope records, preserved in tree rings and ice cores, show that in the distant past, even larger solar particle events have struck Earth. Scientists call them Miyake events. These were more than 1,000 times as intense as the November event. 1,000 times. Imagine that for a moment. If November 11th pushed radiation to 10 times normal, a Miyake event would push it to 10,000 times normal. And here's the uncomfortable truth. It's not a question of if such an event will happen again. It's a question of when. We're living in an era where aircraft depend on electronics more than ever before. Fly-by-wire systems, computer-controlled flight controls, microelectronics everywhere. This makes modern aircraft safer and more efficient. But it also makes them vulnerable to something our grandparents never had to consider: radiation from space. The researchers from Surrey are now calling for all aircraft to be equipped with radiation monitors. Why? Because during a severe radiation event, the radio links that connect pilots to air traffic control on the ground can also be disrupted. Picture this. A pilot notices his systems acting erratically. He tries to contact the tower, but the radio connection is dead. He doesn't know a GLE is occurring. He doesn't know whether he should descend to a lower altitude or change course. Dr. Ben Kluwer from Surrey put it bluntly: if you're in the air and can still communicate with air traffic control, you could descend to a lower altitude or change your latitude. But what if you can't communicate? What if hundreds of aircraft are affected simultaneously? We're heading into solar maximum right now. Cycle 25 is expected to peak in late 2025, possibly extending into 2026. That means in the next 12 months, the probability of an even stronger event is higher than it's been in the past 20 years. Let me paint you a picture. It's an ordinary Tuesday morning. 200 aircraft over the Atlantic, families heading home from vacation, business travelers rushing to meetings, a pregnant woman in seat 23A, completely unaware. Then a GLE hits, 50 times stronger than November 11th. Radio communications fail, computers start producing errors, flight control systems behave unpredictably, and there's no plan B.
Is that scenario likely? Probably not. But is it possible? The scientists who launched those balloons on November 11th would tell you absolutely.
On November 11th, 2025, we got a reminder that we live in a cosmic environment. The sun, our life-giving source, can also threaten us. The event was only a fraction of what happened in 1956 was only a fraction of what tree rings tell us about the past. The scientists in England made history with their balloons. They gave us the first three-dimensional real-time data of such an event. But the bigger question remains, are we prepared for what might come next? The next major solar flares will come, almost certainly in the next year or two, as solar cycle 25 reaches its maximum. And when they come, thousands of aircraft will be in the air. Pregnant women, families, people just like you and me. Is the aviation industry ready? That's the question we should all be asking. Should airlines invest in real-time radiation monitors? Should passengers be warned when such events occur? Should there be protocols for pilots to follow during a GLE? I'd like to know what you think. Leave your thoughts in the comments below. Should the industry be doing more? Or am I being too dramatic about a 2% event? I read every single comment. Because here's what keeps me up at night. November 11th was a warning shot. A relatively mild one by historical standards. But next time, we might not be so lucky. And next time, we need to be ready.